All right, welcome to Success CHEM 130 class. And today we are looking at atoms and isotopes. You're all welcome. Isotopes are atoms. Please write down. Isotopes are atoms that have the same atomic number. Isotopes are atoms that have the same atomic number. In bracket, put number of protons. In bracket, put number of protons. Isotopes are atoms that have the same atomic number. In bracket, put number of protons. Number of what? Protons. Isotopes are atoms that have the same atomic number. In bracket, put what? Number of protons. Please close the brackets. But have different mass number. Isotopes are atoms that have the same atomic number, in bracket, number of protons, but have different mass number. Class, this phenomenon is known as isotopy. This phenomenon is known as what? This phenomenon is known as isotopy. Isotopes are atoms that have the same atomic number but different mass number. Class, if you look at chlorine, class 17, the atomic number is the same, but coming to the atomic mass, you have 35 and you have 37. Class, it's first important to note that we have two types of atomic. We have atomic number. When talking about atoms, we have the atomic number and we have the atomic mass. We have the atomic number and we have the atomic mass. Class, it's already a well-known fact that atoms contain proton, neutron, and electron. It's a well-known fact that atoms contain what? Protons, neutron, and electron. From our secondary school days, when we started studying chemistry, our teacher used to tell us that atoms are the smallest indivisible particles. But indivisible meaning that it cannot be divided. But later on, we found out that atoms can actually be divided into sub-particles. Because as the study of science progressed, other discoveries were made. And one of the discoveries that were made was that atoms can be broken down into protons, neutrons, and electrons. Class, the proton has been found to be positively charged. The neutrons are negative. Electrons are negative, while the neutrons are said to be neutral. These three particles makes up an atom: proton, neutron, and electron. Class, we know that the number of protons contained in the atom of an element is known as the atomic number. The atomic number is the number of protons contained in the nucleus of the atom of an element. And class, when you represent an element, the atomic number is usually written as a subscript. Look at this number below here. It's the atomic number. So when you want to write an element, the atomic number is the one that you're seeing below, while the atomic mass is the one you're seeing above here. Another name for atomic mass is mass number. So while the atomic number is number of proton only, the atomic mass is number of proton plus neutron. All these I'm saying are foundations to what brought about isotopy. I believe that everybody here knows somehow, you know that atomic number is this, and atomic mass is this, you know it. We're trying to create a foundation to what led to isotopy. Now, so atomic mass is number of proton and neutron found in the nucleus of the atom of an element. Class, notice that in these two definitions, none of them mention electrons. Atomic number picks only protons, number of protons only. Atomic mass, proton and neutron. So what about the electron, class? The electrons are found outside the shell. Class, only the protons and neutrons are stored deep within the nucleus of the atom. That's why you never hear of loss of proton and neutron. They can't be lost because they are embedded deep within the nucleus of the atom. But electrons can easily be lost or gained because they are not well stored. Compared to proton and neutron. So because electrons cannot be trusted, because they can easily be lost anytime or gained anytime, we don't include them in the mass of an atom. If we include electrons, then the mass of an atom will keep changing every time. Anytime electron is lost, the mass will change, because when someone has lost an electron, they have calculated it in the mass already. It means you have to reduce the mass, right? And when you gain electron, you have to increase the... So electron is unstable, it can easily be lost or... But we are always sure of proton and neutron. They are never lost or gained. Their numbers remain constant. Except in radioactive elements. You know that radioactivity can occur that will lead to decay, right? That one affects the nucleus. Only radioactive decay affects deep within the nucleus. And not all elements are radioactive. Not all elements are what? So not all elements can undergo radioactive decay. So apart from that, apart from radioactive decay, the proton and neutron are quite safe. But electrons doesn't even need radioactive decay to be lost or gained. Now class, moving on. So you can see that these numbers below are the same. Atomic number is the same, but atomic mass is different. Class, a formula must then be used, class, because there's not going to be a confusion. If someone asks us for the atomic mass of chlorine, we'll be asking ourselves, do we say 35 or do we say 37? So a formula was made that helps us to determine the average mass of elements that exhibit isotopy. A formula had to be made to help us determine the average mass of elements that exhibits what? To avoid confusion, because if someone says what's the atomic mass of chlorine, some people will say 35, some will say 37. It's creating confusion and inconsistency. So a formula was made that helps us to determine the average mass of any element that exhibits isotopy. And class, when you want to determine the average mass of an element that exhibits isotopy, we consider two things. We consider the relative abundance of that element. The relative, or RA means relative abundance. And we also consider the AMU of that same isotope. AMU means the atomic mass unit, the atomic mass. These two things are considered when we want to determine the average mass of an isotope. Class, this chlorine 35 has its own relative abundance. It's measured in percentage. And this chlorine 37 has its own relative abundance measured in what? Percentage. Class, it is a accumulation of this person's abundance and its AMU with this person's abundance and its AMU that leads to what? The average mass or the average atomic weight of an isotope. That's what leads to the average mass or the average atomic weight of an isotope. So class, the relative abundance multiplied by the average atomic unit, AMU, of this one, plus the relative abundance of this guy times the average atomic unit of this guy. So let us say an isotope has two isotopes, A and B. The average atomic weight, so now you understand why we need to find the average, right? Because there's confusion between 35 and... If they say what is the atomic mass of chlorine, some people will say 35, some will say 30. Which one is causing confusion, inconsistency? Okay, let us create a formula that helps us to, so we can have one number, and that's also 35 points. If they ask what is the atomic mass of chlorine, it's 35 points. That 0.5 because they found the average between 35 and 37. How did they do it with this formula? Follow me, please. Follow me, please. Follow me. Class, we have, so when I say RA, you know what I'm talking about, relative. RA, let's say we have two isotopes, isotope A and isotope. I don't want to say chlorine 35 and 37 in the formula because it won't always be chlorine. So let's call this guy A, let's call this guy what? It's RA of A multiplied by AMU of A plus RA of B multiplied by AMU of Class, note that this RA is relative abundance and measured in percentage. This might look simple until they will meet the two abundance and has to find them. And when that happens, you will need to be good. Class, as we said, proton, neutron, and electron. Before taking question on isotopy, simple questions can be asked of you in the exam. To determine number of proton, neutron, and electron for a particular element, class, where they can really catch you is if they give an element that you don't know the mass. For example, class, if I'm asking you to find the number of proton, neutron, and electron for Se, 2 minus. Determine number of proton, neutron, and... Class, the exam is subjective. The exam is subjective. Class, determine number of proton, neutron, and electron for Se, 2 It's different if they give you calcium. We all know that calcium is 20, right? If you count your first 20 elements, calcium will fall on number hydrogen, helium, lithium, beryllium, boron, carbon, hydrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium. Calcium is number 20. And the atomic mass of calcium is what? 40. So to get the number of proton for calcium is this 20. Proton is what? 20s. Neutron, class, the number of neutron is the atomic mass minus the atomic number. You get number of what? Neutron. Anytime they ask to find number of neutron, is the one on top minus the one, the atomic mass minus the atomic number. 40 minus 20 is also, and class, number of electron is also the same thing as number of proton, 20. Please take note. As long as the elements remain on charge. If I taught something like this in this class, if you remember, when I taught you number of proton, neutron, and what? Electrons. Yes, I taught it. I taught it earlier than the topic, but this is talk and postage it. This is where it falls under proton, neutron, electron, the entire isotopy. Class, proton is 20, neutron is 20, electron is, because this calcium is on charge. This calcium is what? But let us look at charged calcium. Let us look at charged. Charged calcium means that calcium 2 plus. Because if you write down the electronic configuration of calcium 20, you have 2882. Class, the likely thing calcium would do is to lose 2 electrons. And in chemistry, when you lose electrons, you acquire a positive sign. And the number of electrons you lose will determine what you carry, the charge you carry. So calcium will lose 2 electrons to become calcium 2 plus. Anytime you say a positive on an element, just know it has lost. And anytime you say a negative, know that the element has gained. The number that element is carrying is the number of electrons the element has either lost or gained. The number the element is carrying is the number of electrons the element has lost or gained. So Ca2 plus means that, plus means you have lost, please. Please don't mind the plus and think that plus means you gain now. No, in chemistry, when you have lost, you are positive. When you have gained, you are negative. So 2 plus means you have actually lost 2 electrons. I wish they could have made it easier by saying plus should be gained, because that one makes more sense, right? And minus should be, but the reverse is the case in chemistry, so take notes. When you are plus, it means you have lost. Class, why would calcium want to lose 2 electrons? To attain an octet configuration. To attain what? There are some special elements that are stable in the first 20 elements. Helium, neon, argon. These elements have the required number of electrons for each of their shells. They are called noble gases, inert gases. They are balanced. Every other element wants to be like these noble gases. Helium has 2 electrons. Neon has 10. Argon has, if you check the electronic configuration, because we have shells that's 2 electrons, KLMN. The K shell requires just 2 electrons to be filled up. The L shell requires 8 electrons to be filled up. The M shell requires 8 electrons to be filled up. And the N shell can go as 18 and more electrons to be filled up. Class, any element that can provide the exact number of electrons that the shells need is said to be stable. It's said to be a noble gas. Not all elements can give the shells the required number of electrons they need. Class, helium has just 2 electrons, because if you count the number of elements, hydrogen, helium comes next. Helium is number 2, meaning he has 2 electrons. Class, helium has just 2 electrons, and K shell just needs 2 electrons. You can see why we say helium is stable. It's a noble gas. When elements are stable, they don't need to react, class. The reason why we have chemical reaction in chemistry is because of instability of elements, class. When you see sodium reacting with chlorine, it's not because sodium likes chlorine. It's because sodium is 281 and chlorine is 287. Class, chlorine needs just 1 electron from sodium to be stable. Sodium needs to release this 1 electron to also be stable. Hence, they form NaC. So when you see elements combine to form compounds, it's not because they like each other, it's because of what they need from each. That's why you rarely hear things like neon chloride. Have you ever heard neon chloride before? Neon does not need to react with anybody, it's stable. Argon doesn't need to react with anybody because what? So elements actually react because they want to obtain an octet or duplet configuration. Why do we say duplet in the case of helium and octet in the case of neon, argon? If you keep going, krypton, we have other xenon, other noble gases outside the first 20 elements. You have krypton, you have xenon. Are we together, class? So that's the main reason why elements are reacting. So you see why calcium wants to lose 2 electrons, because If he loses 2 electrons, then it's stable. Because K shell needs 8. Sorry, K shell needs 2, he has 2. L shell needs 8, he has. M shell needs 8, he has. This 2 is the liability. So I need to let go of this 2 and it becomes stable. But class, even if elements can lose electrons or gain electrons to become stable, they will not quite be like noble gases. Class, noble gases need to change to ions to be stable. They are not charged and they are stable. But elements, in order to be stable, we now turn to what? Charged. They will not be charged. They will be in their charged state. They will become ions. Anytime an element loses or gains electrons, it's no longer a normal element again. It now becomes an ion. Any element that is carrying a charge is no longer just an uncharged element. It's now what? An ion. So you cannot quite still be like noble gases, because the noble gases do not need to be an ion to be stable. They are just naturally stable. So class, Ca2 plus is now formed. What brought me to all this is that class, remember I told you the electrons are the one that can easily be lost or gained. So class, number of proton and neutron and electron for Ca2 plus. Proton and neutron will not change, still 20, but electron can no longer be 20. So this is uncharged calcium and this is charged calcium. In this uncharged calcium, it is still 2882. 2 electrons have not been lost yet. These 2 electrons have not been lost. In this uncharged, these 2 electrons have not been lost. But in this charged calcium, 2 plus means you have lost 2. So if you had 20 electrons before, what will you have now? 18. So class, you must be careful when they say find number of proton and electron for an element. Check, is it charged or? And check how many electrons has that person lost or gained to show it. But class, proton and neutron remains the same. The same way you get proton and neutron here, same way you get proton and neutron, they are never lost or gained. They are never lost or what? Gained. But class, the problem now is that this is even simpler because calcium is a common element. It's in the first 20 elements. This is selenium. The first challenge you're going to have here is, what number does selenium fall in the element table? And the exam, imagine thinking of selenium in the, that's where the problem will start. Because they give you, I think if they give you something like aluminium, you will get it, right? Everybody knows that. What number does aluminium fall on the element table? 13, thank you. So everybody knows that aluminium is 13. And if it's 13, what does atomic mass? 27. Remember that atomic number is written below, right? Atomic mass is written. Atomic number is written below. Atomic mass is written. If they ask you for aluminium, you will get it. Proton. Proton is what? What's neutron? You say 27 minus 4 electron. Class, as long as aluminum is not carrying a charge, number of proton and electron are the. For uncharged, when elements are uncharged, number of proton and electrons are the. Once aluminum now acquires the charge Al3 plus. This is normal aluminum, this is aluminum 3 plus. Why is aluminum 3 plus? Because aluminum is 2A3. 2A, electronic configuration 2A. 2 in the K shell is happy. 8 in the L shell is. But 3 in the M shell is not happy. Why is M shell not happy? M shell needs 8 electrons to be happy. M shell needs 8 electrons to be. So to aluminum, these 3 electrons, liability. Aluminum is finding a way to release these 3 electrons. Aluminum is finding a way to do what? It's finding a way to give out that 3 electrons. So that it can be stable. Every element wants to be stable, right? So by giving out 3 electrons, when you will lose 3 and become Al3. So number of proton will not change, it's still 13, right? Neutron, 14. Electron will now be what? 10. When it was uncharged, electron is 13. When it is charged, it has lost 3 electrons. 13 minus 3. 10. 13 minus 3 is what? And this is not even just normal selenium. This is charged selenium. Even normal selenium, some people don't know where it is on the element table. Now charged. This SE2 minus means that selenium has gained 2 electrons, right? When you are minus in chemistry, you have actually gained. When you are plus, you have lost. Good. I want that to be sure in your head. Now, let's do a simpler negative before I now treat this selenium. Let us look at phosphorus 3 minus P3. What number does phosphorus fall on the element table? You say? 15. Phosphorus is 15. What's the atomic mass of phosphorus? It's 31. It's 30. I think I've taught this class how to get atomic mass from atomic number, right? If it's an odd number, you want to get the atomic mass, multiply it by 2 and add 1. Anytime you know, if you can know the atomic number is easiest to know. If you can know the first 20 elements, you've gotten the atomic number, right? Hydrogen, 1. Helium, 2. Lithium, beryllium, 4. Those numbers, if you can arrange them in that pattern, you've gotten the atomic. Now, from atomic number, you cannot get the atomic mass. Class, how? If the atomic number is an even number, multiply by 2 to get the atomic mass. But if it's an odd number, multiply by 2 and add. And I gave you the exceptions, right? In that class when I taught it, I gave you the except. Some elements do not follow that. They are just 3 or 4, I think. I listed there. That they do not follow the rule. I think one of them is hydrogen, right? Nitrogen. Chlorine does not also follow the rule. Because chlorine is 17. And make mass of chlorine is 35.5, which we'll get from isotopy later. Nitrogen is number 7 on the element table. 7 times 2 is 14. If you are following this rule, 7 is an odd number. You're supposed to add 1, right? But you not add 1. Hydrogen is, of course, 2. You not add 1. So, class, these 3 do not follow the rule. But every other element follows that rule, class. If the atomic number is even, multiply by 2, you get the atomic mass. If the atomic number is odd, multiply it by 2. 15 times 2, 30. Then add 1, 30, 31. Class, they guess find number of proton, neutron, and electron for selenium 2 minus. Option A, 34p, 45n, 36e. Option B, 45p, 34n, 36e. Option C, 36p, 34n, 45e. Option D, 38p, 40n, 34e. Option E, 48p, 40n, 24. Class, actually the question they gave 79 above here to help you. They gave what? Class, what does 79 mean? Atomic mass. Because they wrote it up, right? If they wrote it down, what do they have meant? Atomic norm. Class, I think with this option you can get the answer actually. Because atomic mass is number of proton plus neutron. Check each of these options. Which of the proton and neutron gives 79? 45 plus 34, is it 79? Because atomic mass is number of proton plus neutron, it's not 79. Is it 79? 35 plus 34. 45 plus 34. 34 plus 45 is 79. Do you know that? 36 plus 34. 36 plus 34, 70. So this cannot be the answer. 38 plus 40, 78. This cannot be the. 48 plus 40, 70, 88. This cannot be the. It's between these two. Now, is it A or is it B? Class, I think it's A. Why do you think it's A? Let me see if you're already thinking what I'm thinking. Because of the 2. Minus means that you have gained 2. So class, if 45 is the answer, means that the electron before was 45. If you gain 2 electrons, it should be 47 here then. Which is wrong, right? But this makes more sense because 34 plus 2, 36. So A is the answer. A is the what? Hope you all get it. Because 34, let's say this guy was on charge. If this guy was on charge, it means that it will have been 34, 45, 34. If it's on, because on charge means the number of proton and neutron are the number of proton and electron are the same. If it's on, but charge means that number of electron will be plus 2 because it has gained 2. So that would be 34, 45, 30. This cannot be true because gaining 2 electrons, 45 plus 2 is 40. But we're having 36, so this cannot be. So A is the answer. Look at this class. Cu2 plus 6329. Find number of proton, neutron, and electron. Cu2 plus 6320. Proton is what?
29.
Electron.
34. 31.
Electron, this.
Okay, electron 34.
Electron. 20. 2 plus means you have lost. So you subtract 2 from 29. 2 plus means you have lost. Now, neutron. 63 minus 29, right? 34. Now, let's take question on isotopy. Let's take question on what? Calculate the atomic mass of an element X. Calculate the atomic mass of an element X. Calculate the atomic mass of an element what? X. Calculate the atomic mass of an element X, which has two naturally occurring isotopes. Which has two naturally occurring isotopes. Calculate the atomic mass of an element X, which has two naturally occurring isotopes. Which has two naturally occurring what? Isotopes. Calculate the atomic mass of an element X, which has two naturally occurring isotopes. Given that the isotope X107, given that the isotope X107 has an atomic mass unit, of 106.90509. Given that the what? The isotope X107, given that the isotope what? X10, this is how you write it, X107 has an atomic mass unit, of 106.90509. Of 106.90509. And percentage abundance, that's what's called relative abundance. Percentage abundance of 51.84%, and percentage abundance of what? 51.84%. And percentage abundance of what? 51.84. While isotope X109 has an atomic mass unit of 108.90474. Class, first mistake you should not make. Never approximate any of these things. So every number in this parameter is important. Don't go and say me approximate. You're stressing me. Let me approximate it. If it's subjective exam, you just say that you will not know that you're even wrong. So, X109, atomic mass unit of 108.9047, and percentage abundance of 48.16%, and percentage abundance of 48.16%, and percentage abundance of what? 48.16%. What else to calculate, class? Calculate the what? Atomic mass of an element X. That means they ask you to find the average atomic weight. Because you're having 107, you're having 109. There's a problem. Which one are we going to call it? Are we going to call it 107? Are we going to call it 109? That's where the problem lies. That's where the problem. Class. Applying the formula. Relative abundance of A, let this be A and let this be B. Let X107 be A, let X109 be B. We have twice stops. Relative abundance of A is 51.84. Using the formula, 51.8. You say multiply it by what? Multiply the relative abundance by the AMU. What's the AMU? 106.905 multiplied by 106.9050. Plus, they say add it, right? Plus 108.90474. That is relative abundance of B, sorry. What is the relative abundance of B? 48.90509. Class percentage, so divide by 100. Please, don't forget. Divide by what? It's percentage, so divide by 48.16% multiplied by the AMU. 108.9047. So take the abundance multiplied by the AMU plus take the abundance multiplied by the AMU. If you do everything very well, your final answer will be 107.87 AMU. Class, I hope you don't expect me to multiply for you. You should be able to multiply and add, right? So don't waste time. 107.87 AMU. Let's take the next question. Yes, welcome back. Second question now. Chlorine has two isotopes, chlorine 35 and chlorine 37, with atomic mass units of 34.9689, with atomic mass unit 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 of what? 34.9689 AMU and 36.9659 AMU respectively, and 36.9659 and 36.9659 AMU respectively, and 36.9659 AMU respectively. And 36.19659 AMU what? Respectively. Given that their relative abundance are 75.77%, given that their relative abundance are 75.77% and 24.23%. And 24.23% and 24.23% respectively, and 24.23% respectively. Calculate the average atomic mass of chlorine. Calculate the average atomic mass of chlorine. Calculate the average atomic mass of chlorine. Calculate the what? Average atomic mass of chlorine. Calculate the average atomic mass of chlorine. Class, quickly demystify that question now. Don't forget, multiply this by this, and multiply this by, then add them. When you multiply this by this, whatever you get, this by this, whatever you get, add the two of them. If you are correct, after doing the two, I expect you to have 35.453 35.453 AMU. what? Your class, quickly. Class, it's now time to be working on your speed, not just that you can get the answer. Class, you need to start working on getting the answer in good time, in good class. You will not have all the time in the exam, so you need to start working on your speed. At this point, if someone gives you a question, don't just check if you can get it, check how fast you can get it. Because our exam is going to be timed. Our exam is going to be what? Timed. Anybody's done already? Class, learn how to use your calculator to make sure you are not right. Class, nobody wants to see you solving in chemistry exam. Do you know the funny thing? I think I need to ask this our 200 level student. I think what happened was, some people even carry empty sheet to solve. They say you should drop it. Learn how to punch your calculator. Practice it. That's what you need to practice. You might not even be allowed to carry rough sheet to solve, because some people might use that as carried expo. You will now see that after every chemistry and you see the table, people have solved on the table. Everywhere is filled with solving. Practice with your calculator. This thing, use calculators on the top analysis. If you are very good, use calculator this, multiply by this. Bring out your answer. Work with your speed. Okay, everyone, just be. Question 3. Oxygen atom consists of 3 isotopes. Let's look at isotopy. What if there are 3? We have looked at 2 examples where there are just 2 isotopes, right? What if there are what? 3 isotopes. What if there are 3 isotopes? Oxygen atom consists of 3 isotopes. Oxygen atom consists of 3 isotopes. Oxygen atom consists of what? 3 isotopes. Oxygen 16, oxygen 17, oxygen 18. Oxygen 16, oxygen 17, oxygen. Oxygen atom consists of 3 isotopes. Oxygen 16, oxygen 17, oxygen. With atomic mass units of 15.99468 AMU, with atomic mass units of 15.99468 AMU, 16.99884 AMU, and 17.9972 AMU respectively. Class, in case I was too fast on the board. With atomic mass units of 15.99468 AMU, 16.99884 AMU, and 17.9972 AMU respectively. If the relative abundance of these isotopes are 99.759%, if the relative abundance of these isotopes are 99.759%, 0.037%, and 0.204% respectively. If the relative abundance of these isotopes are 99.759%, 0.037%, and 0.204% respective, determine the average atomic mass of oxygen. Determine the average atomic mass of oxygen. Class, what do you do? Multiply this by this, multiply this by this, multiply this by whatever you get here, add it to what you get, then add it to what you get. I'm intentionally not solving it. I want you to make a mistake and correct yourself. If I'm solving it for you, you will not know, you will not make one mistake now that will make you correct yourself for exam's sake. If someone keeps helping you on the exam day, everything will now look strange to you because you've never been solving by yourself. Change this to percentage all over. Class, if you are correct, your final answer should be 15.999 AMU. I want to see the first answer. I want to see the first. You're done? Good, I like that. Good. Speed, speed. Speed. Good, good, good. Second answer. Good, 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 good. Who can punch this thing without pressing right anything in a book? Start pushing yourself to that levels. So I'll punch this thing, I will not write anything in any book. But what if you don't have paper to solve? And you that is not writing, you don't write solution and you're not doing nothing. You're not writing. But a solution. You are done. No. Good, good. Most people are done. Most people are pushing you to be better. Go ahead. Mike. yes. Class, last question on isotopy. Are you ready? Class, as far as I'm concerned, you're done with this. Faith is calling those things that's been not as. So I have faith that you're done with 15.999 AM. You 15.999 AM. If you are here, you're very good and you are very good. You are God blessed you with the gift of copying in the exam. Like you can giraffe a lot. See me after the. Let's harness your skills. Let's harness your. God bless you with that gift. You can sit here and you're copying from Amaka in the last seat there. You know what? Class. Let's look at calculation of percentage relative abundance of two isotopes when their average atomic mass is given. Write down. Calculation of percentage relative abundance of two isotopes. Subheading. Calculation of percentage relative abundance of two isotopes when their average atomic mass is given. Calculation of percentage relative abundance of two isotopes when their what? Average atomic mass is given. Calculation of percentage relative abundance of two isotopes when their what? When their average atomic mass is given. Class, have you noticed that so far they don't omit this abundance? They always give us, right? They will give us the atomic mass unit and the abundance. Atomic mass unit and the. What if they omit the abundance and this thing we have always been looking for, they now give us? When they give you this average atomic mass and they give you the AMU, but they say find the abundance. If they give you the average atomic mass, they give you the average atomic what? Mass, and they give you the AM. But they now omit this percentage. They say find the percent. Let's look at the question. Two naturally occurring isotopes of an element X. Two naturally occurring isotopes. Two naturally occurring isotopes of an element what? X. Two naturally occurring isotopes of an element X. Two naturally occurring isotopes of an element what? X. Two naturally occurring isotopes of an element X. Two naturally occurring isotopes of an element X. Two naturally occurring isotopes of an element what? Please, if you just came in while I was teaching and you have not registered for this class, please do so immediately or you'll be going to have sent many people out. Before you came in, I've sent many people. Anybody that stayed back was those that paid. You've not paid, you don't have your access key, you have not paid for this line. You came in while we're teaching. Go ahead and make a payment now. If you're paying cash, signify and let me know. Or please, you'll be excusing us immediately. Please do not wait till once I post this, after this class work, I will come to you. Don't wait till I get to you, please. If you've not paid, you've not registered, you're not going to be allowed today. So if you see them sitting down, they have registered. Make your payment to this account immediately. Please do not let me get to you before that. I saw some of you that just came in. Do not let me get to you before you make your payment. It's either you are going out now or you're depositing an amount for the class. Immediately, please do not let me get to you. That's the instruction. If you've not paid and sitting down, I don't want to get any excuse. Do so immediately. That's the account number there. So I don't want to hear there is network. Go outside and get the network. The name you see there, you see a Scottish name. You say what? It's not a Nigerian name. Prince Will. Forget about the other ones. When you see Prince Will, you're on the right. Prince Will. Prince Will. Now, follow me. Quickly, please. Make the payment. If you're sitting down and you have not registered, please do not let me get to you. It won't be interesting because I already gave you the warning. Go ahead and make a payment or you excuse us. Quietly be a gentleman and excuse us. Two naturally occurring isotopes of an element X. Two naturally occurring isotopes of an element X have the following masses. X85 have the following masses. X85 comma, then you put 84.9118 AMU. X85, put a comma, 84.9118 AMU.
This your way you write your mass, the atomic mass. You said that top, right? Is this supposed to be at the back of the X or the front of the X?
Anyone, if you like sitting in front in a car, put it in front. If you prefer back seat, put it in the. You can put it on top of your head too. Sometimes. Class, let's go. X85, 84.9118 AMU. X87. Please, those just coming in. Same instruction I'll give. If you've not registered for this class, kindly register or carry that your drawing board and just follow that side you came in. Follow that side you came in. Or if you don't like that door, you can use this door too. X87, 86.9092 AMU. Two naturally occurring isotopes of an element X have the following masses. Have the following what? X85, 84.9118 AMU, and X87, 86.9092 AMU. Calculate the percentage abundance of the isotopes of the element X. Calculate the percentage abundance of the isotopes of the element what? X. If the average atomic weight of X is, calculate the percentage abundance of the isotopes of the element what? X. If the average atomic weight of X is, calculate the percentage relative abundance of the isotopes of the element X. Calculate the percentage relative abundance of the isotopes of the element what? X. If the average atomic weight of X is, if the average atomic weight of X is 85.4678 AM, is 85.4678 AMU. Class, we're looking for abundance of these two isotopes. So we're looking for two unknowns. We're looking for the abundance of S85 and abundance of S80. So we're looking for two things at the same time. But class, the good news is this. Let us call the abundance of this guy A%, abundance of this guy B%. B what? One thing is sure, A plus B should give you 100. 100 what? A plus B should give you what? 100. If A plus B is 100, means that A must be 100 minus B%. 100 minus B what? Make A subject of the what? If A plus B is 100, make A subject of formula. Bring B to this side, become minus. Because we're looking for two abundance. Abundance of X85, let's call it A. Abundance of X87, let's call it. This guy that we're actually looking for normally has not been given to. This thing was what we have been looking for in the last three examples, right? The average. It's been given to us now, but they're asking us to find the two abundance. It's not just one, it's two. If it is one, they ask us to find, they give us the other one. I think this one is 40%, and they say find the abundance. What we have done? 100 minus. So they know that it will be too simple, so they have to omit the two. Because they give you one abundance, just say 100 minus this guy, get the second. But they omitted the two. So formula is average atomic weight, which is 85.4678 equals relative abundance of A is what? Relative abundance of A, we call it A%. A, that's A over 100. But A% is 100 minus B, right? So we call it 100 minus B all over. Remember that abundance of this first isotope is A%, right? But A is 100 minus, that's 100 minus B, multiplied by AMU of the first isotope, multiplied by the AMU of the first. What's AMU of first for 84? Plus relative abundance of B, this isotope B, Abundance of B is just B%, that's B over multiplied by the AME of B, second isotope. It's 6.909 to... School is very quiet. What happened? Is that students traveled or what? School is what? Have they brought out timetables? Have you noticed that school is very quiet? They just... Even Mandela boys are not making noise. Why is the BB over? How? Because percentage. Now, abundance is a percentage. The percentage of A is A%, percentage of second isotope is B. A% means A over, B% means B over. Why? Eh? Eh? Moving forward, class. Moving forward. Let's go, let's go, let's go. So 84.9118. 84.9118 times 100 minus B into bracket 100 minus all over what? I multiply this by this, right? Plus 86.9092 times B is 86.9092 all over what? This times this all over what? 100. You can see I'm solving this, so I know when to come in. But since I expect that I should be able to do multiply, this one is not straightforward. That's why I'm solving it. Class, remember that everything must be equal to the average atomic mass unit, right? Let's expand this bracket. 84.9118 times 100 is what? 8491.1 minus 84.9118 times minus B. 84.9118 all over what? Plus 86.9092B all over equals, what's the average? 85.467 equals what? 85 equals 85.467. See what I'm going to do, class. Follow me. You can clean this up. This is the question I can clean. We have a question in our book now. Class, I'm going to multiply everybody by 100 so that 100 cancels 100, 100 cancels 100, and this guy multiply by 100. Or multiply both sides of the equation by. What we are going to have is I want to use 100 on top to key denominator 100 under. 100 on top, denominator 100 under. I'm going to have 88491.18 minus 84.9118b plus 86.9092b equals to this guy times 100 is 8546.78. Note that I did not carry the 100 over 100 again. There is no more over 100 over. Because why is there no over 100 again? I multiply all through by what? Multiply this guy by 100. 100 will cancel 100 on top. 100 will cancel 100 on top. 100 this guy will multiply by. Multiply this guy by 100 means move decimal place 2 places. 1. 8546.7. 8546. Instead of 85 points, is now 1 to 8546.78. Class, these two are like terms. B, they both carry B, right? Minus 84.9118 plus 86.9092. Someone should help me. What is minus 84.9118? 1.9974B, right? Equals to 8546.78 minus, let it get does not have become to this. It becomes what? Minus, right? 8491.18. So 1.9974B equals to this minus this 8546.78 minus 8491.18. 55 point. Hope you are not approximating. Making B set of the Divide both sides by 1.997. 1.997. 1.9974 cancels 1.997. So 55.6 divided by 1.9974. You see? 27.836%. 27.836%. B is therefore 27.836. B is 27.836. If B, we have gotten B, can we now get A? A is 100 minus B. A is 100 minus B, which is 100 minus 27.836. That will give us what? 72.164%. And we have gotten A and what? B, the two abundance. The two what? Abundance. But this is how you solve for abundance. When abundance is omitted and other things are given. Class, this is the main formula. Any other thing I did were just processes to get my answer. I could have let it here for you and say find B. You're a science student. You should be able to get B. The sense of getting A in respect to B so that we can have only one unknown. Imagine if this abundance was A and this was B. I will have two unknowns, right? It's more difficult. So I have to write A in terms of B because A plus B is 100. So make A squared of the plus B come to this side become 100 minus. So that A is 100 minus what? B. Meaning that anywhere I see A, I can replace with 100 minus what? Because normally, class, the abundance for this side should be A, right? Abundance for this side should be B. But A is 100 minus B. So I don't need to write A here. I just put 100 minus B percent. That's 100 minus B all over. What is the abundance of putting 100 minus B here? So that I can have only one unknown. You see, it's only B, B. I can now solve for... Class, it's easier to solve for one unknown than to solve for two unknown at the same... Class, are we following? It's easier to solve for one unknown than to solve for two unknowns at the same time. Class, are we together? That's what we did here. So once you get the first unknown, you can now put it into this expression and get the second unknown. And get the second what? Unknown. Cut what off? They just gave me the value. I'm not going to calculate it. It's what they gave me, I wrote down. Did they approximate? This is what they gave me. I don't know whether did they cut it off? No, I don't mean that full now. Like, you want to write the full calculator. See me after the class, eh? See me after the class. It's 27.836 is okay, eh? What does that they say in Igbo? Is it Zukwanike or what they call? What does that thing mean? Rest, Abi. What is the correct pronunciation? The last time that thing was raining. Now, class, moving forward. Take a class. We'll take a class. The average atomic mass unit of gallium. This is the last question we'll do on isotopy. Then we'll go to control number. The average atomic mass unit of gallium. The average atomic mass unit of what? Gallium, G-A-L-L-I-U-M. The average atomic mass unit of gallium is 69.72. The average atomic mass unit of gallium is 69.72. The average atomic mass unit of gallium is 69.72. That is a classwork I'm giving you. The average atomic mass unit of gallium is 69.72. Calculate the percentage abundance of its two isotopes. 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 Gallium 69 and gallium 71. Gallium 69 and gallium 70. With mass unit, with atomic mass unit of 68.9257 AMU, with atomic mass unit of 68.9257 AMU and 70.9249 AMU respectively. With atomic mass unit of 68.9257 AMU, with atomic mass unit of 68.9257 AMU and 70.9249 AMU respectively, with atomic mass unit of 68.9257 AMU and 70.9249 AMU respectively. Class, I'll pause the recording and I want you to have a little time to solve. Your percentage abundance for gallium-69 should give you 60.27% if you are put in two decimal places approximately. And for gallium-71, 39.73%. If you have anything around this figure, you're on the right track. So this should help you know if you are correct or not. Please, I'll give you 30 seconds more, then we'll start quantum number. So let's go to quantum number now. Class, if you did not arrive at this answer, ensure that you arrive at it when you get home. This should give you something to do. If I do it, you will not do it. Ensure you arrive at this. Your colleagues have arrived at it, so it's not difficult, it's not insurmountable. You can do it. You can follow the same approach. This should give you something to now look forward to go and solve and make you read. So make sure you arrive at this. Don't be happy until you arrive at the answer. Quantum number, class. Before going to quantum number, actually, there are some things you should have been taught. There are some things you should have been, before writing quantum, but the main topic should be quantum number. But let's go. Follow me. Follow me, follow me, follow me, follow me, follow me. Class, we have taught you electronic configuration. If you have to write the electronic configuration for chlorine is number 17, right? Follow carefully, follow. The electronic configuration for chlorine is 287. 28. But class, this is one way of writing electronic configuration. There's another way. There's what we call the spdf configuration. This one is the shell configuration, KLM. There's the spdf configuration. Class, it's time to introduce you to what we call orbitals. Class, that K element is shells. When you write configuration in 287, K shell, L shell, M shell, is shell configuration. Class, shells are not the final place where electrons are stored. Class, shells undergo configuration to give what we call orbitals. These shells undergo configuration to give what we call what? Hence, orbitals are called subshells. Are called what? Shells undergo configuration to give orbitals. Hence, orbitals are called sub. We all know about shells, right? The shells, K shell, L shell, M shell, N. But class, shells produce orbitals. Hence, orbitals are called sub, and orbitals produce blocks. Orbitals produce what? Blocks are called suborbitals. Sub what? Or subshells. Or sub. If you are ever asked, what's the final point where electrons are stored? Is blocks. Is what? So class, the first visible position of electrons is shells. For shells produce orbitals. Orbitals give rise to block is the final point of storage of electrons. Class. So in the shell level we have K element shell. In the orbital level we have S, P, D, F. We still have G, but for the level we're not introducing it to G. We have S, P, D, F. Just like even in shell, we have K element O shell. But as usual, different stage of knowledge requires different exposure. Class, SPDF orbital. Class, the S orbital is called the sharp orbital. S for sharp. P for principal, D for diffuse, F for functional, F for sharp, principal, diffuse, functional. Now, each of these orbitals, just like shells have the number of electrons they can store, just like shells have the number of electrons they can, orbitals also have the number of electrons they can store, class. And you're aware that the s orbital can only take 2 electrons maximum. It can take less than 2, but not more than. The p orbital can only take 6 electrons maximum. It cannot take more than 6. The d orbital can take 10 maximum. F can take 14. So just like shells have the number of electrons they can take, orbitals also have the number of electrons they can maximum. Class, doesn't mean that if you don't put 2 here, if you put 1 here, it will enter, but it's not going to be happy. 2 is the optimal electron that will make S say, okay, we are good. P is what? 6, we are good. D is, F is. Now, class, according to Abel's rule, according to what? Abel's rule, when electrons are arranged, we arrange electrons in orbitals of lower energy level before that of higher energy. Class, the reason why we want to write electronic configuration is start with K before L before, because K has a lower energy level compared to L. Class, moving from K shell to L shell to M shell, the energy level is increased. The energy level is what? Likewise, moving from S to P to D to F, this increased energy level. Class, so when filling electrons in orbitals or shells, we start filling from orbitals of lower energy level before orbitals of higher energy. This is due to what? Abel. Abel actually means energy, class. In chemistry, Abel means what? The term Abel means energy. In this topic, we'll be looking at what we call degenerate orbitals. What are degenerate orbitals? We look at a lot of things that can come out in your exam. You can't write chemistry exam and not have questions on quantum number. Class. So Abel's rule tells us that when filling electrons in orbitals or shells, we fill from orbitals of lower energy level before those of higher energy. Because there are actually 3 rules that guide us in quantum number. Abel's rule, we have On's rule of maximum multiplicity, On's rule of maximum what? And Pauli's exclusion principle. Pauli's what? On's rule of maximum multiplicity, 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 and Pauli's exclusion. Should be good and conversant with these rules. Abel's rule is one that tells us that when filling electrons in orbitals, we start from lower energy level to what? Higher energy. So it is wrong to first fill electron in the M shell before K shell. It's wrong to fill electron. Now let me show you energy level in the SPDF class. Class, do we say shells give rise to orbitals? Class, so orbitals don't exist on their own. For every orbital, there's a shell that produces, a shell that did what? Class, when you see 1s, 1s means that this orbital was produced by the first shell. When you see 2s, it means this s orbital was produced by the second. When you see 2p, this p orbital was produced by the second. 3s, 3p, 3d, 4s, 4p, 4d, 4f. Why do you think that the first orbital, why do you not have 1p? Because 1 is K shell. K shell cannot produce p. K shell cannot produce what? Do we know why? K shell can only take 2 electrons. How can it produce p that has 6? That's what? 6 electrons. Now, I want to show you the energy level that involves these orbitals. For class, unlike shells, they will just have KLMN. For orbitals, we can't just have SPDF. Every orbital is accounted for from the shell it's produced. So orbitals don't exist on their own, they come with a number. 5s, 5p, 5d, 5, 6s, 6p, 6d, 6. Let's stop here. Class, don't forget that S can take 2 maximum, P can take, D can take, F can take. So this is 1s, this is 2s. I'm showing you the energy level. 2p, 3s, 3p, 4s, 3d, 4p, 5, 4d, 5p, 6, 4f, 5d, 5F, 6D, 6F. Class, follow me. Class, you must follow this arrow when filling electronic configuration of elements. You must start from the lower energy. The lowest energy level is the 1s. After 1s is 2s. Actually, 2p has a lower energy level than 3s. Because of the shell is from. 3p has a lower energy level than 4. 3d, 4p, 5. 4d, 5p, 6s. So once you write 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, 6f. And they have to write the spdf configuration class. If someone says just write the electronic configuration of sodium, sodium is number 11, you say 2H1, this is the shell configuration, KLMN. But the spdf configuration is not going to be 2H1, it's going to be 1s. Now class, you're going to start filling from 1, you are going to 11 electrons, right? You are going to what? So you start from 1s, start from the lower energy level. Class, 1s, how many electrons can s take? 2. After 1s, who are you to go to next? 2s. S can also take 2, right? After 2s, what's next? 2p. How many can p take? While you are adding up, make sure you don't exceed the level. 2 plus 2. 10. Only one more electron, right? So the next person we are going to carry only 1. 3s. Interesting class. Are you aware that this spdf configuration can help you to determine the block an element falls under in the periodic table? Are you aware that we have 4 blocks in a periodic table? Just like a periodic table has the group and the periods. Your periodic table can vary into groups and what? Period. The vertical columns are the groups, the horizontal rows are the periods. Your periodic table also divides into 4 blocks, class. There's some elements that belong to the S block of the periodic table. Like sodium belongs to the S block class. Class, the last block here represents the block the element belongs to. So by writing out the correct spdf configuration of an element, you can determine the block of periodic table the element belongs. Let's look at phosphorus. Phosphorus is 15. So let's go now, class. At a point then, you will forget about this table and you just find out that you know how to write it without thinking of the table. That's how learning takes place. Firstly, you start with the table, then after a while, I'm not writing this thing without table. You have now learned by association. Can we do the one for phosphorus 15? What will it be?
1s2, 2s2, 2p6, 3s.
After 3s, what's next? 3p. 3p what? We are going to 15, remember? 2 plus 2. 10. 12. How many are going to get 15?
3.
Phosphorus is in the P block of the periodic table. The last orbital of the element tells you the block it belongs. Later on, I'll tell you how to use this to determine the number of unpaired electrons, class. Electrons can either be paired or you could be asked to determine the number of unpaired electrons in phosphorus. I'll just bring out the block of phosphorus. This P has 3 blocks, Px, Py, P. Now, following On's-rule, class, On's-rule said we fill singly before pairing. When filling electrons in orbitals, we fill singly before. So I'll put 1, 1, 1, and 3 electrons are filled up, right? It means that these 3 electrons are unpaired because in each block, to fill a block to full capacity, you need 2 electrons. You need what? 2 electrons. So it means that phosphorus contains 3 unpaired. In the exam, you could be asked to determine the number of unpaired electrons in phosphorus. You could be asked to determine the magnetic property of an element. Class, if an element can either be diamagnetic or paramagnetic. Diamagnetic or what? We'll get to all those things step by step, step by. Let's not overcomplicate it. Let's just achieve knowing how to write SPDF first. Then determining quantum number. We're going higher and higher. Now, class, phosphorus 15 is 1s2, 2s2, 2p6, 3s2, 3p3. Now, what did they ask you to write the SPDF configuration for calcium 2+? Not just calcium. Calcium 2. Calcium 2+ must mean that calcium has lost 2. So for calcium 2+, what are you going to have?
1s2, 2s2, 2p6.
What is normally calcium? 20, right? But calcium 2+ means he has lost 2 is A. So you are targeting 18, not 20. 1s2, 2s2, 2p6.
3s2, 3p6.
2 plus 2, 4. 10, 12, 18. Normal calcium would have continued to 4s2, right?
Yes.
But calcium 2+ means it has lost 2 electrons. Class. You could also be asked to write the electronic configuration of an element in terms of a noble gas. This is what we call noble gas configuration. Noble gas what? Class. Who is the closest noble gas to sodium? Neon. Neon is number 10, right? So neon is 2 plus 2, 4 plus 6. Class, it means that this first 10 electrons represents neon. I can replace everybody here with neon, and my configuration will be neon 3s1. This is the noble gas configuration of sodium, class. When you ask to write the configuration of an element in terms of a noble gas, it means that express the element in terms of the closest noble gas to it. What's the closest noble gas to phosphorus? It's still neon. It's still what? Neon is number 10, so cover this 10. 2 plus 2, 4, 4 plus 6. Replace this first 10 with neon and write out the remaining. Neon, 3s, 2, 3p. This is what we call noble gas configuration. Some people are missing classes. What it will take you 2 hours to read, I'll just show you on the board. Because sometimes when you're reading vaguely, you don't know what will come out. You're reading without experience. You're reading you're not reading everywhere. I'm reading on my own. Someone that has been teaching this thing for a number of years is more exposed and more experienced to show you just topic that will cover in 2 hours. And sometimes check when you're trying to read, you take more time because you're trying to figure out a lot of things. Textbook will not tell you what they did here. But someone has gone through that stress for you, just show you. It's faster. It's what? Some of this is not as if you cannot read them on your own, but it might take more time for you to break them down, each of them. And you don't know the one that is important, the one that you should give more emphasis, and the one you should not. It's not as if some of you are not intelligent. Some of you can read chemistry on your own, right? And pass. But sometimes tutorial helps you to bring out the more important ones. This one you saw when I'm teaching, I hammer on some things, right? When you're reading, you don't know the one to hammer, you're not reading, and that's again, tutorial helps you to learn with your fellow colleagues. That's, it's iron sharpened iron. That's ginger. When you see your friend get it, you also want to get it, right? Your friend, you're pushing each other, you're pushing each. Those are different advantages that when you're just isolating yourself reading on your own, you might not get. You might not what? And you read vaguely. Which one do you know that will come out? In the big test, open out your big chemistry textbook. Where do you want to start from? No direction whatsoever. But you can see at some point I will slow down, say that thing again. You can am on that thing. I know based on my experience that thing is important. It's important. That's the essence of classes. But some people are missing this now. If you ask your friend now to do some of it, they can't do it. And they are reading, but they can't do it. We'll get further and you see more things we'll be learning. Now moving forward, class. So you've understood noble gas configuration, right?
Yes.
Is anybody still lost? You're still lost? Write down the noble gas configuration for someone like carbon. Carbon is number 6. Class, carbon is 6 electrons, so start from 1s. 1s, 2. Who is the next person? 2s and 2p. We're using this, but you understand that we're using this to fill it, Abby?
Yes.
Now, alpha. Carbon is number 6. Now, we want to write down the noble gas configuration. What's the closest noble gas to carbon? Helium. You that say you don't understand, I'm looking at you. Helium. Helium is number 2. So this 1s2 covers helium, right? So replace 1s2 with what? And what will be left? So this is the noble gas configuration for carbon. Write down the noble gas closest to it and then fill up the remaining. We've done noble gas configuration. We've done normal configuration. Now class, there are 2 elements that do not exist. There are some things that happen. We have 2 elements we're going to look at now that are of very importance. Class, chromium and copper. Chromium and what? Chromium is number 24, copper is number 29. It's not in the first 20 elements. Follow me. Chromium is number 24, copper is number 29. Chromium, let's following this, what we're going to have 1s, someone should help me, let's follow the table. 1s, 2, 2s, 2p,
3s2, 3p6, 4s2,
After 4s is what? 3d. 3d, 4. 3d what? 3d what?
4.
Copper is 29. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9, 20. I want to show you something. Follow. Following the rule, this is it, right? But you know that this answer is wrong. You know why it's wrong? It's what we call stability of orbital. Stability of what? Stability of, follow me. Class, orbitals are stable when they are singly filled all through, or when they are completely filled all. Now follow me. Class, the s orbital produces the s block. Remember that I told you that it starts from shell to orbital to block, right? It starts from shell, orbital, then the s orbital produces the s block. The s block contains only one block. The p orbital produces p block, and p block contains 3 blocks. The d orbital produces 5 blocks, and the f orbital has 7. This is the final point of storage of electrons, class. This is the final point of storage of what? Electrons. Class, a block can only take 2 electrons, and no 2 electrons should have the same orientation. No 2 electrons should have the same what? Class, there are 2 possible orientations of electron. We have the clockwise and the anti-clock. The clockwise orientation, we use a positive plus. The anti-clockwise use a negative. Because the s orbital produces the s block can only take 1 electron. Can only take what? 2 electrons. So 2, because 1 block can only take 2. The p block has 3 blocks. Each one can take 2 electrons, right? The d has 5. Each can take 2. So 5 times 2, 10. The f has 7. Each can take 2. 7 times 2. You see why f can take 14 maximum. Notice that one electron is going up, the other must go. It's Pauli's electron principle that tells us no 2 electrons should have the same. They may have the same principle, they may have the same azimuthal magnetic, but the spin, there's what we call the spin quantum number. The spin, there are 2 possible spins of an electron, the clockwise spin and the anti-clockwise spin. The clockwise spin and the anti-clockwise. And follow me. Stability of orbital. Stability of what? Class, there are 2 ways in which this p orbital is stable. I want to look at p orbital. If you have only 1 electron in each space, or you have the full 2 electrons, it's stable. Is what? Stable. Anything other than these 2 is not stable. The same thing for d orbital. If you have d orbital, d is 5, right? D is what? 5 blocks. D contains 5. If it is singly filled, it is stable. That means everybody has 1 electron, only 1, or everybody has the complete 2. Then the orbital is stable, the block is stable. Class, anything like this is not stable. Look at this p, they are both stable. Look at this. One person, some have 1 and some have 2. Mixture of 1 and 2 is not stable. If everybody has 1, let everybody have 1 till the. If everybody has 2, let everybody have 2 till the. Mixture of 1 and 2 is not stable. Or maybe someone is even absent completely. It's not also stable. So these are the only 2 conditions for orbitals to be stable. When they are singly filled or when they are completely. Class, s orbital is always stable as long as there's at least 1 electron inside. S orbital is always. So class, there's no difference between 1 or if s orbital has 1 electron, it's stable. If he has 2, it's also. It's only when he has 0 that is not stable. Now class, what is the importance of this information, class? In chromium and copper, follow me carefully. Everything I'm doing, I'm building towards something. In chromium and copper, class, notice chromium. That chromium in this d orbital is d4, right? 3d. D has how many blocks? 5 blocks, right? 4 electrons, class. if you want to fill 4 electrons in a block, class, when you want to fill electrons in block, untrue tells us that we fill singly before pairing. Fill singly before. Class, you want to put 4 electrons in this block. You know that each block can take 2 electrons, right? Don't go and start saying 1, 2, 3, 4. This is the wrong way of filling electrons. This is the wrong way of what? You first gave this guy 2 and feed it. You know, each block can take 2, right? You feed this guy 2, feed this guy 2, and you have feed the 4 electrons. This is the wrong way of filling electrons. When filling electrons, give everybody 1, 1. Okay, let's just go 1 round. Just like in a party and you're sharing rice. You know that rice will soon finish, and maybe they still drink. Why not? You give these people drink rice, give these people what? Drink. So someone has eaten some, maybe there's a samosa, there's all those snacks. It's okay, you chop pop first. How we together? Chop that one. But you now shared rice here, you shared salad here, the wine, shared it. Have you been in a party before and you're in the last seat and you're watching? Rice is coming towards you. There's rice, there's chicken, there's everything inside the rice. Chicken, there's salad, everything is all the mende. There's even jollof and fried rice inside the same. So you're happy, you are giving glory, you're even singing worship song. As it's coming towards you, they find out that jollof rice is no longer available, only fried. But they see chicken and there's all the mende inside. As it's coming towards you, chicken has not ended, only jollof rice. As getting closer, only water is coming towards you. Where's the rice that's finished? Say, what's going on? You now say, let me go and change it and go to that. You now move to this side. Move to this side. Say, sharing rice here. Say, sharing rice and meat. They go on here. This people is like, this is against me. Class, what I mean is, you feel everybody, give everybody 1, 1. If your party is meat, take small meat first. Then rice, serve small. 1, 1 before pair. Now, filling singly before pair. Now, you have 4 electrons. You are filling singly. Class, this d orbital just needs 1 more electrons to be stable. It just needs what? It needs 1 more electrons to be stable. And s orbital beside d has 2 electrons. And this s orbital beside d, even if you remove 1 from it, it doesn't affect s. Remember what I told you about s? If s has 2 electrons, it's okay. If it has 1, it's still okay. So there will be a transfer of 1 electron. This happens only in chromium and copper. I'll show you how it happens in copper. To ensure stability of the d orbital, there will be transfer of 1 electron from s to, so this is 4s, 3d. Because with 1 more electron here, d orbital is what? Stable. To ensure the stability of the d orbital. To ensure the stability of the what? So class, if you ask to write the configuration of chromium and you just follow the normal method 1s2, 1s this, you have had 4s2 and 3d4 and you'll be wrong. You need to remember that for chromium and copper, they have special cases. That is transfer of 1 electron from s to what? D. Same thing happens with copper, class. Anytime you go to a party, the caterer that they hire to share food, as soon as if you want them to favor you very well and give you food, just call the caterer. Say, give me your card, I have an event soon. I'll need a lot of caterers. Give me your card. You're really doing well, take this 500. Watch what they will give you. They will serve you food. They might even leave the bride and the groom and come and give you food first. Say, now you they marry now, chop. Because they are now trying to please you for the next walk now. Because after this walk, they want another. Just collect their card. Give me your card. We need some. A very big event we are hosting, and we need some. Okay, I've not eaten. Shall bring food first. Come together. They go bring food. You go chop it. S class D is 5 blocks. D is what? D is 5. Class, you have 9 electrons. 1 fill singly first, right? Now pair. 9 means that there's 1 more block that is not. But with 1 more electron here, this d orbital is stable, right? But what makes someone stable is if they are double everywhere or single every. And s orbital is here again. It happens chromium and copper. S orbital does not mind giving you 1 electron. With 1 electron, s is still stable. It doesn't affect him. The way transfer of 1 electron from this place to this 4s1, 3d. Chromium and copper, please take note. Chromium and copper, please take note. This spdf configuration of element. Now, let's now look at type quantum number now. There are 4 basic types of quantum. Go and practice more of this. SPDF, practice more. There are 4 types of quantum number. Class, quantum means what? Energy, right? Quanta, quantum, singular, and plural means energy. Four types of quantum number. We have the principal quantum number. We have the principal quantum number. We have the azimuthal quantum number. We have the magnetic quantum number. We have the spin quantum. We have the principal quantum number. We have the azimuthal quantum number. We have the magnetic quantum number. And we have the spin. Class, the principal quantum number, N, the symbol is N, azimuthal is L, magnetic is M, spin is MS. They are their symbols. The magnetic can be ML, you can call it ML. Let's start with principal quantum number. The principal quantum number describes or characterizes the energy level. The principal quantum number describes or characterizes the energy level. The principal quantum number describes or characterizes the energy level, in bracket put shell. In bracket put shell. After energy level, in bracket put what? Shell. The principal quantum number describes or characterizes the energy level, in bracket put what? Shell, which the electrons occupy. Which the electrons what? Occupy. Which the electrons do what? Occupy. The value of N, class, principal quantum number symbol is okay, write down, it is symbolized with the letter N. The principal quantum number is symbolized with the letter what? N. The principal quantum number is symbolized with the letter what? N. We use N. The symbol for principal quantum number is what? Letter N. And the value of N ranges from 1, 2, 3, 4, and you continue. So 1, if someone's principal quantum number is 1, it means that that person belongs to the first energy level. Do not forget that I said that each of these shells have energy levels, right? They have energy. So when someone's principal quantum number is 1, it means that you belong to the first energy level. When your principal quantum number is 2, it means you belong to the second energy. The more the number of shells an atom has, the more the energy level. Shell 1 means the lowest energy level. Shell 2 means the higher energy level. Shell 3. So the principal quantum number is characterized by a number of shells. Number of what? If someone contains 3 shells, it means your principal quantum number is what? 3. If it requires 4 shells to fill up an electron of an atom, it means the principal quantum number for that atom is what? 4. The principal quantum number is the number of what? Shells. So if you can get the number of shells, you've gotten the principal quantum number. Let's go to azimuthal. First question they can ask you, another name for azimuthal is called what? It's called subsidiary or angular quantum number. Subsidiary or angular quantum number. Angular momentum quantum number, sorry, angular momentum. Subsidiary or angular momentum quantum number. Subsidiary or what? Angular momentum quantum number. Subsidiary or what? Angular momentum quantum number. This quantum number describes the geometric shape. This quantum number describes the geometric shape. What are we talking about? Azimuthal. This quantum number describes the geometric shape of the orbital where the electron resides. This quantum number describes the geometric shape of the orbital where the electron resides. This quantum number describes the geometric shape. The geometric what? Shape of the orbital where the electron resides. The geometric shape of the orbital where the electron does what? Resides. It tells us about the subshells present in an energy level. It tells us about the subshells, in bracket put orbitals. It tells us about the subshells, in bracket put what? Orbitals. It tells us about the shells, in bracket what? Orbitals present in an energy level. It tells us about the what? Soft shells, in bracket what? Orbitals present in an energy level. The value of L ranges, what does L represent? Azimuth. Azimuth symbol is L, right? The value of L ranges from 0, 1, 2, 3. Class, if someone has azimuthal quantum number of 0, class, I can predict the orbital it belongs. It belongs to the S. If someone has azimuthal quantum number of 1, P. Azimuthal of 2, D. Azimuthal of 3, F. So class, each azimuthal quantum number gives us an information about the orbital orientation of that particular constituent. And class, if someone's principal quantum number is 1, his azimuthal quantum number is always at least less than, at least a number less than what? N minus 1. So the relationship between azimuthal and principal is L equals to N minus 1. The relationship between what? Azimuthal and what? Principal is L equals to N minus. Class, at least if your principal quantum number is 2, class, your azimuthal quantum number can never be greater than 2. If your principal quantum number is 2, class, the possible values of azimuthal is either 0 or the possible value of azimuthal is always 0 or what I mean is that your azimuthal should always be at least one number lesser than your principal. It's impossible for an atom to have the same principal and azimuthal. That's what I'm saying. And it's also impossible for the azimuthal to be greater than the principal. The azimuthal is always at least one value less than the principal. So if someone's principal is 2, his azimuthal must either be 0 or, if someone's principal is 3, his azimuthal is either 0, 1 or 2. If principal is 4, azimuthal is 0, 1, 2, 3. 0, 1, 2. These are the possible azimuthal. Now I'm telling you now that if your azimuthal quantum number is 0, you belong to an S orbital definitely. If your azimuthal quantum number is 1, P. Azimuthal is 2, D. Azimuthal is 3, F. So class, at this point, if I'm told that the principal quantum number, you're not staying here, you're staying here. N, principal quantum number N is 2. And someone's azimuthal is 1. Class, remember that I told you that it's wrong to just mention P without telling us the shell it comes from. Every orbital comes from a shell, remember? Did I tell you that? That every orbital comes from a... So you never see S alone, S, or you just see P, or you see D. You always see the number beside the S, or the P, or the D, the number, the shell that produced the orbital, the shell that produced the... So class, if someone's azimuthal quantum number is 0, it's S, but which of the S? The principal will tell me which of the S. Class, if someone's azimuthal quantum number is 0, look, let's look at if someone's a principal quantum number, if principal is 2, azimuthal is 1. It means you are 2, L is 1 means P. 2, P. 2 what?
P.
I'll come again. If someone's principal quantum number is 3, N is 3, principal is N, right? And azimuthal L is 2. Class, N means the shell, L is 2 means the orbital. What orbital does L is 2 fall under? D. It means that the orbital designation is what? D. Because someone can tell you, they can be told, that given that the principal quantum number of so and so is N is 3 and L is 2, determine the orbital designation. Determine the orbital designation. The orbital designation is 3D. 3 because the principal is 3, meaning the number of shell. L is 2 means what? D. When L is 3 is what? F. When L is 0 is what? S. Are we following class? Now, let's go to magnetic. We'll see what magnetic will tell us now. Because class, even this D has different orientation. Class, N is 2, L is 1. We said 2p, right? But class, there can be 2px, there can be 2py, there can be 2pz. Magnetic tells us the exact type of p. Magnetic tells us which block of the p does it belong. Yes. Azimuthal tells us that you are p, but magnetic tells us what kind of p are you. Class, are you aware? Follow me. Follow me, follow me, follow me, follow me, follow me, follow me. Class. Are you aware, class, that when you have this P block contains 3 blocks, remember? D block contains 5 blocks. Each block has a name. Azimuthal will not tell you which of the P block. It will just tell you that it is P. Magnetic we are going to next will tell us the exact P. Is it PX? Is it PY? Is it P? Tell us the exact D. This D is 5. We have dx squared. We have dy squared. We have dx squared minus y squared. We have dxz, dyz. The exact D, the exact. Right and magnetic. Magnetic quantum number describes the orientation in space of an orbital of a given energy level and the shape. Magnetic quantum number describes the orientation in space of an orbital of a given energy level. Magnetic quantum number describes the orientation in space of an orbital of a given energy level. Magnetic quantum number describes the orientation in space of an orbital of a given energy level and shape. And what? Shape. It tells us how many suborbitals are in an orbital. It tells us how many suborbitals are in an orbital. It tells us how many what? Suborbitals are in an orbital. It tells us how many suborbitals are in an orbital. It tells us how many suborbitals. Yes, it tells us how many suborbitals are in an orbital. How many suborbitals are where? In an orbital. Note that the magnetic quantum number depends on the azimuthal quantum number. The magnetic quantum number depends on the azimuthal quantum number. The magnetic quantum number depends on the azimuthal quantum number, and its value ranges from minus L to plus L. From minus L to what? Plus. The value of the magnetic ranges from minus L to plus L. The value of the magnetic ranges from what? Minus L to plus. The value of the magnetic ranges from minus L to plus. Class. So the magnetic depends on the azimuthal, class. Follow me. The magnetic quantum number depends on the what? Azimuthal quantum number. Class. If someone's azimuthal, class, let's start from principal N is 2. Azimuthal L is 0. Magnetic M ranges from minus 0 to plus 0, which is still 0. So it's just 0. There's nothing like minus 0 and plus 0. So class, when L is 0, magnetic is also 0. But class, so when L is 0, magnetic is 0. But class, when L is 1, the value of the magnetic ranges from minus 1 to plus 1. What are the numbers from minus 1 to plus 1? Minus 1, 0, and the numbers that from minus 1 to plus 1 are minus 1, 0, and when L is 2, class, my magnetic will range from minus 2 to plus, that's minus 2, minus 1, 0, 1, and when L is 3, my magnetic will range from minus 3 to plus, so my magnetic will be minus 3, minus 2, minus 1, 0, 1, 2, 3. Minus 3, minus 2, minus 1, 0, 1, 2, 3. Are we together, class? Class. When L is 0, what orbital are we talking about?
S.
S orbital. S orbital does not have S, X, Y, and Z. But coming to P orbital, class. When L is 1, what are we talking about? Is it not P? And P is minus 1, 0, and class, minus 1, 0, and 1. Each block has a number. Class, if you have P, so class, follow me now. I want to show you something. Remember when I asked you a question, when I said, when N is 2 and L is 1, what's the orbital designation? You said 2P. 2 what? Now what if they say when N is 2 and L is 1 and M now is minus 1 and M is what? When N is 2, you say 2. When L is 1, remember when L is 0 is S. When L is 1 is P. When L is 2 is D. When L is 3 is. So they say when N is 2, N is 2. When L is 1, they're talking about P. When M is minus 1, what type of P are talking about? P? P what? What's J God? Someone say, who sent me? Who sent me go science? Who sent me go? Now that our brain has rested, let's move. Let's move. Follow me. Class. Px, Py, Pz. So if someone tells you that when N is 3, L is 1, and M is 0, what is the orbital designation? You will say 3 for the shell. When L is 1, P. When M is 0, 3P. 3P. If someone say when N is 3, L is 1, M is 1. When N is 3, you say 3. When L is 1, P. When M is 1, Z. 3P. That's for P. Now let's go to the one for D. Right, and then we'll go to the one for what? D has zone name too. Some of you, after your first semester break, you go home, you see your junior brother, your junior sister, they give him chemistry assignments. You say, bring it, I can do it. What do they want to give you that I have not seen? Bring it, I can do. What God cannot do does not exist. Bring it. Let me show myself. I don't attend tutorial and I don't learn. Some of you have run away from your assignment before. Say, bring it, I can do it. And say, you know they do assignment before. What happened? So, no, you have more confidence now. Is it chemistry? I've learned chemistry more than you. What did they do for secondary school? Bring your assignment. This is your assignment. You are not in university. There's no way you pass through Uniport. I say, you finish your Uniport. So well done, you try. It's not easy. Remember that you can finish your Uniport. It's not easy. It's stress. Say, you finish that school. It's not easy. First year 1, first semester. Year 2, year 3. Some of you 5 years course. Some of you 4 years course. You finish. You try. It's not easy. Now follow me. D. You have dxy. You have dxz. You have dyz. You have dx squared minus y squared. You have dz squared. These are the 5 possible designations for the d orbitals. All this you should have learned in secondary. For school knows that they did not teach you. So if I wish I had you haven't never heard of it before. Oh, sir, you're giving me a headache, sir. You've never heard of it be. So that's why school is saying do it again, do it. And if you knew some of these things very well, you would have gotten a higher JAM score plus TMA score, some of you. That's just the truth. Or you see, you want to go and write JAM again, we don't blast it and get from us easily. That course they actually wanted, we don't blast it and get it. dxy, dxz, dyz, dx square minus y square, and dz square, and dz square. Class, when we say the orbital designation is a d orbital, when L is 0, what do we have? S. When L is 1, P. When L is 2, D. When L is 2 is what? But class, magnetic terror, which D are we talking? class, don't forget that the value of the magnetic depends on the azimuthal, right? When L is 2, our M will be minus 2 to plus, that's minus 2, minus 1, 0, 1. So this is minus 2, minus 1, 0, 1. This is the D block. This is the D. Minus 2, minus 1, 0, 1, 2. So follow me. So if someone say when N is 4 and L is 2 and M is 0, what is the orbital designation? That will be what? 4, N is 2, D, M is 0, Y, 4D, Y, Z, 4D, Y. When N is 3, L is 2, all these markers are even tired of the chemistry too, and M is 2. What will it be? 3, L is 2, D, M is 2, Z squared, 3DZ. So every block has a name, every block has a name. Class, I'll end it with spin quantum number so I can enter math 120. So I can enter math 1. Class, we always have chemistry on when? Fridays, right? Is it Thursday or Friday? Friday is physics. We always have chemistry on Thursday. Wherever I stop here, I'll continue on Thursday. If you miss the class, make sure you are fully registered so that I can add you to the paid members group. Any class you miss is recorded and you have access to it. I limit the access to only our paid members. If you look at our general online group, you see people are crying, sir, I'm looking for chapter 1 in your YouTube channel. You will not see it. And we shall send me chapter 3, 4, and 5. Someone says, I say, look at you. Who will send you? I told you, there's a way you did it. I told you, some of you are taking, you just go and check, you see. There are some videos you cannot see on my, even if you go to my YouTube channel, you will not see them. I unlisted them. The owner of the channel has the right to unlist some videos. So that if you go to the channel, they are there, but you cannot see it. Only if I give you permission to see it. And those in our paid members group, any video I send to you is because I send it, that's why you can see it. Though. If you went there normally on your own, you can't see it. If you don't go through the channel I sent to you, you cannot see the video. That's why you see, so if you go to our general group, people are saying, sir, send me chapter, send you what? Have you registered? Send chapter 3, 4, and 5. So I should sit down and record for you and send for you like that. I don't have anything I'm doing. I'll just sit down and be recording for you. You'll be at home. And they don't even want to pay for it. It's not easy recording every day. It's stressful. It's what? See the stress. Standing, teaching, making sure that you're organizing yourself. It's not easy. It's not. So if someone say bring just 3K for something that will teach you the whole course, recording every day. Someone say that size is too much. Why? People don't value education. Education is very. So even people feel that they are paying too much for class. 3K. For something that will start and be teaching. Because you don't value it, you see 3K as too much to learn a course, a full course. But when you paid your school fees, you paid 200 and something thousand, and you have not understood the main school fees you paid. And someone said, bring 3K to learn that same course, it's now too much. But you pay 200 and something, and you're not understanding your lecture. Each lecture you don't understand is worth 200 and something you paid. And you're not angry with that one. But when someone says, bring 3K, let me teach you, it's now becoming too much in your eyes. So it's, sometimes I don't understand how students think it. Now, because it's just 3K per course, and you're not even paying for all courses. And then they'll still record and send for you. They'll still do physical class, online class. And that 3K is not still too much, looking big in someone's eyes. What's 3K? It's fine. Now, spin quantum number. Let's end it with spin quantum number. Spin quantum number is symbolized by MS. Spin quantum number is symbolized by MS. It describes the orientation of the spin of an electron. It describes the orientation of the spin of an electron. It describes the orientation of the spin of an electron. It describes the orientation of the spin of an electron. An electron can only spin in two possible directions. An electron can only spin, you didn't get the first part, I should come again. It describes the orientation of the spin of an electron. The spin quantum number describes the orientation of the spin of an electron. The spin quantum number describes the orientation of the spin of an electron. The orientation of the spin of an electron. An electron can spin in only two possible directions. An electron can spin in only two possible directions. One, the clockwise or upward spin. Clockwise or what? Upward spin. Put this in brackets. Two, anti-clockwise or downward. Anti-clockwise or what? Downward spin. Class, in our next class, I will be breaking down the dynamic involved between the upward and downward spin and how to understand their importance in the block structure of an atom, in the block structure of an atom. So see you in our next chemistry class. Now we'll switch over to Math 120.